Hello, everyone. Thank you so much for taking the time to see our final project presentation. First of all, I want to introduce the title of our project. That's going to be Real-Time Demographics of Possible Consumers. So for today's presentation, we are going to have the next agenda. We're going to start by speaking a little bit about our team. Then we're going to start with the project itself, talking about the resource questions, then going into the project summary, we're going to speak about the different phases that we went through. After that, we're going to speak about the tools and the software and the different techniques that we use to get our final product. After that, we're going to talk about the database that we chose. And finally, we're going to have a real-time demonstration of the solution that we built. So each of us has different backgrounds and experience that when we put it together, we were able to uh, have a team with different skills and point of views that I think that plays in our favor at the moment of developing this project. So our project manager has past experience leading different teams and projects. Our developer has a lot of experience with in the technology field. Our data analyst is also very a person who has a lot of experience in the technology and develops an engineer uh, projects. And me, I am a psychologist with experience in the research process in social sciences. So going to the topic of our project, uh, we in this project we are going to be working under XYC Corporation. They are looking for a solution that are that is going to be able to visualize the different characteristics of their target population, so they can have a better understanding of the uh, people who are buying their products, and they also want that this visualization of the target population is continually being updated. A little bit about the description of the web application that we constructed. So this is a Flask web application hosted in AWS EC2 US East 1 T2 micro instance. Uh, so from so this Flask web application, what it does is fetches the user data from a URL, stores it in a MongoDB database, and from there the Flask web application, what it does is uh, uses an HTML using an HTML code and Google Charts. We are able to first of all put that information into our web application and also create the different charts which are going to be updated periodically. So our research questions for these visualizations that we wanted to create in this web application are three. So what are the occupations that XYZ customers have? We also wanted to ask about the proportion of men and women of these customers. And finally, which is the age distribution of this population. So we can go into more detail about which were the steps that we followed in this project. First of all, we planned the project, which meant we divided the different tasks that each of us had to complete this task. Then we also developed the research questions, so where we wanted to this project to go. And from that, we also select the data. We collected data. We chose where we were going to where we were going to store the data. That's Mongo database. And after that, we went onto the process of the web application creation. And finally, when we had our web application where we could fetch the data, we started created the visualizations uh, based on the data that we fetched.
So for the languages that were used for our projects, we used Python. We also used HTML and Flash framework and Google Charts as well for our project. Some other tools that we used GitHub, MongoDB, AWS, and JavaScript. Now, for the technologies used, we first off used HTML. This code, HTML code creates a front-end user data dashboard, and it visualizes user data using Google Charts and interacts with the Flask API to dynamically update information based on user input. And it provides an engaging and informative way to explore and understand user demographics. Now, the page utilizes external libraries as well, which is to help enhance the functionality. It includes jQuery for simplified JavaScript, Bootstrap for styling, and Google Charts for data visualization. Now, for Google Charts, the script is then loaded into the Google Charts library, and it specifies the code charts package, which initializes the charts with the draw chart functions, which makes the AJAX request to a Flask API endpoint to fetch the user data. Now, for drawing charts, three functions, that is draw bar charts, draw pie charts, and draw column charts, are responsible for creating different types of charts. So that's bar, pie, and column charts. And the chart represents the distribution of user data based on the occupation, gender, and age. Now, for the page allows users to interact with the API through a form, and the users can choose to retrieve all items, which is a range of items or a specified item by ID. So depends on the user. They can choose to do any of that. And depending on their selection, the corresponding input boxes are then displayed. We also used handling user input. Um, so the script includes functions like the handle user selection and handle API request to manage the UI changes based on the user input, and to also handle API requests accordingly. The latter function constructs the API URL based on the selected endpoint and user input. Then the next function uses update results table, which is responsible for dynamically updating a table with the retrieved user data. Now it creates a bootstrap styled table and populates it with user details. So some of these details include user ID, age, gender, occupation, and zip code. Now the Flask web application periodically fetches user data from a URL. It stores it in a MongoDB database and provides routes and API endpoints for data acquisition and retrieval. The periodic task ensures the continuous update of data, and also the application is set to run on port 5000 with debugging enabled. Now, the Python code starts by importing these necessary libraries, including Flask for web development, a render template for rendering HTML templates, JSONify for JSON response handling, requests for making HTTP requests, Mongo client from PYMONG, Mongo for MongoDB interactions, um, time for handling time related functions, and schedule for periodic task scheduling. Now, for the functions, I'm going to go through the functions that helped us in our project. One of which was Flask app and initialization and MongoDB configuration. Now, the Flask app is initialized and MongoDB connection details, so like the username, password, class and URL are all set up. Now, for data fetching and MongoDB storage, the function um, is it fetches the user data from a URL and stores it into the MongoDB database, which was named Redsviz, and the collection named Assign. We also had the Flask routes, and also the API endpoints, which is a 3 API endpoints which are defined. We also had the periodic data acquisition. And then we also had the Flask app execution. For the data source, we use the user data set that contains information about different users. The data set is used for analysis and statistical modeling by exploring the distribution of users across different age groups, different genders, and occupations. The data set we chose was to help basically with exploration analysis by analyzing each user's based on their behavioral patterns, especially focusing on occupation and different demographic factors. Now, for our fit gap analysis, what a fit gap analysis is things that we could have done better as a group. And the first thing we as a group thought is that we could have put more visuals for our project. So more visuals would have helped the stakeholder better understand our analysis. Another fit gap analysis as we went on was functionality gap. Now, understanding our functionalities um, because of the time constraints and the project requirements, that's why we had that functionalities gap. And then more data. Addition of more data would have helped broaden the scope to help and answer our business problems. And addition of filters. More filters could have made it more interactive for the user because as humans, we prefer to be able to visualize and interact with our data set to be able to understand it properly. Now, the next thing that's going to happen is that we're going to show you a live demonstration of our project. Thank you.
So we created this web application using Python and HTML and hosted this application on AWS cloud. And the database that we have created for this web application is on MongoDB. So we have created this user data dashboard. So we kind of went through our data set and kind of team decided these three research questions where we kind of created uh, we created three visuals. First showing the occupation distribution, second the gender distribution, and the third that we discussed upon showing the age distribution. So the first column kind of we went through the data and kind of as a team went ahead to create a visual for occupation. So we through this visual we could understand that the most number of occupy the most more number of users were in students, and the least were as doctors, which is around 14, and the homemaker. So this kind of shows a distribution of various occupations in our data set. So the second visual is a pie chart which shows like the 71% of the population is male population, and 29% of the users are female in our data set. And this graph shows the count of people falling in each of the age range, where the most number of users, which is 78, falls under the age category of 30 years, whereas the means lower age of 7 or the higher age of 70 plus has the least if we can see the three APIs that we have created. So the added business requirement of this application was to create three APIs, where one of the API will get all the items, the second will get a range of items, and the third API can get the items by ID. So this API that we have created, it will kind of fetch all the data from the data set. So when I click on submit, so it will take some time to load, and if we can see, like, all the data from the data set is being loaded, fetching from the MongoDB. It is returning all the results and all the columns that our data set has. So on, again, coming on to the next API, which is range of items, so we have put the range to be put on this column age group. So we can get, like, uh, we can put a range for which we want the data to be written, and it will return all the data within that range group. So if you see, right, I passed on like 35 to 50, all the data between all the users between this group age group should be written. So we got all these results, whichever are falling in this category. So coming on again to the third API, which is the last API, where we kind of all, getting a particular record based on the ID field. So let's suppose I want to get, so again, the user ID for the 8 one is returning. So that's all about the APIs. So I'll again ask Rahul to take over and explain the cloud configuration part. Thank you.
Hi, Professor. This is Rahul. I'll move forward to explain the where our website is hosted and the database. So, as you can see, this is the AWS console in which we have launched our EC2 instance named Flask, and we have launched in the US Eastern region, having the instance type T2 micro, which is the basic instance type in the AWS, and which also which has a lesser billing price per CPU, and these are the properties. This is the public IP of our instance, where our user interface is, where is where our website, where our content and all the graphs are hosted. And this is the URL, this is the IP, 34 235 147 155, and this is the Linux. This is the Linux EC2 launched, and also one S3 bucket is attached, and EBS is also attached with our instance. And moving forward to the database, this is our database, which is created in the MongoDB.atlas. First, we have created the cluster, and in the cluster, we have created the database. This is the cluster name, and this is our database. And in that, we are fetching all our data set, all our details through API, and we have make ID as a subject. You can see different object ID. So through this, we are fetching all the informations and the data from the database. uh, yeah, thank you. So moving ahead, I'll let Akash to move ahead and explain for the application file, which is our app.py, and the our HTML file. Thank you.
Code. So we created this Git repository and has uploaded our Python and HTML code, and that where we have written to create this application. So talking about the Python code, so yeah, as stated, this we have created an application designed to web application designed to fetch user data from a URL and store it in MongoDB database and provide various endpoints for data retrieval. So here, if we see first, what we have done is we have imported various libraries from Flask necessary to run this code. So if we talk about this Flask library, which is required to create a web framework for building web application, this render template is used to render the HTML templates. JSON FI is used to convert Python dictionaries to JSON responses, which we are going to use, and the request is used to making since we HTTP request, since we are making a web application, so we need to import that as well. And this PyMongo Mongo client is used to connect to uh, the driver that is used for Python to connect to the MongoDB. And we are importing this time as a time library as well for various time related functionalities, as well as this scheduled library is imported to make sure there was one requirement where we need to run an API to kind of update the database after every 24 hours. So to run that scheduled job, this schedule library is imported. So coming to the first part here, what we have done is we have initialized our application name this using Flask, and we have defined the uh, MongoDB credentials, our credentials, and we have the cluster is now RB R Rahul RB Baldania. This is the cluster that we have created, and we have using this details we have created a URI, so that we don't have to write each of these details each time where we are using. So we created this fetch and store data function. Yeah, this fetch and store data function we have created to kind of fetch this data from this URL. On this URL we have hosted our data set, and we are fetching using this function that we have created. And each of these is splitted and is stored in a dictionary structure on the database. So here what we are doing is we are connecting to the MongoDB using the credentials that we have defined earlier, and storing this data that we are getting from this function. And uh, here we are splitting that and kind of uh, storing it into a dictionary structure. And then we have created a route to manually trigger this data acquisition. Here we are kind of for this function fetch and store data, so that the data can be acquired successfully. And this is to this route is defined to kind of display the data on a web page. And then we have created these APIs route to kind the first one is to get the items by particular ID. And then this is to get this API route is created to get date all the data within a range, where our range is we are using these two columns, the start age and the end age, to define the range in which this API will fetch all the details. And later we have created another API route to get all the data. all the data that is defined in our data set, and then we are returning this data in JSON as a JSON data. and and this last part is to create a batch process job which will run every 24 hours, and will kind of update that the new data which is being coming in. And coming on to the STM, to create the front end of our application, we have used HTML, where we have created this HTML code. So the title, if you see right, we have this title user data dashboard, which we have defined as a title of our web page. Then we have kind of used the Google Charts to import these uh, bar charts or the pie charts that we are using to create the visuals that we have imported using this Google chart, which was defined in our requirement. And then we have created different charts, and we have through ajax call we have fetching the data to show in these different charts that we have created. Like the first one is for the occupation distribution. The second one is again, as we discussed while explaining the functionality, was the gender distribution, which we kind of drew through this pie chart. And then again, we kind of created the third pie chart for the user selections. So we are updating the table here, and at the end, if you see, we have defined the HTML display means all the content that we have, we are showing on our web page is all the properties and everything we have defined in this HTML code. And yeah, I think that's all. Thank you for listening through. This is all about our web application that we have created. Thank you.
We also provide you with a public IP here and our Git repository link as well, so that you can easily access what we've done with our project. I just want to take a moment to thank my team for all the hard work that was put into this project, and thank you so much for watching our video. Have a great day.